Problem number 60. Problem number 60 said, they gave us some requirements. They said that tangent of theta is equal to -1 and that sine of theta is greater than 0, and then they asked us to find cosine of theta. Okay? And so this is oh, I clicked the wrong thing here. Okay, so we need to remember what all this stuff means. Remember that tangent of theta is the opposite over the adjacent. Remember that sine of theta, somebody tell me what that is.
Opposite over hypotenuse.
Opposite over hypotenuse. And what's cosine of theta? Good, good, excellent. All right, so how do I get -1 over 1? Well, we are living in the xy plane, and they gave us a little clue as to where we are. They said that sine is positive. Well, now the hypotenuse is always positive, and the opposite is represented by the y value, right? So when we think of our standard circle, we have our standard circle that goes around the xy plane. Well, that's not a very good circle. I kind of lost my symmetry there towards the end. But any point on the line, which we normally think of, or point on the circle as xy, can be represented by sine of theta, comma, cosine of theta for our special triangles. Oh, shoot, I wrote that down backwards. It's cosine of theta, sine of theta. Okay? And when we think in terms like this gets translated to tangent is equal to y over x. This gets translated to sine of theta is equal to y over r. And cosine of theta gets translated to x over r. And so this cosine sine business, being the xy coordinates on the circle, is usually the unit circle we have a radius of 1. But sometimes we don't have a radius of 1. Sometimes we have a different radius. So I think it's important that I write out that the radius is here. Okay. So it says that sine of theta is greater than 0. That means that that occurs when the y value is positive, which occurs in quadrant 1. And 2. Now we have a negative tangent value. So x must be negative or y is negative, but not both of them. So when x is negative here,
Quadrant 2.
will quadrant 2 work?
Yeah.
Because x is negative, y is positive, so that would work, right? I need a different color here. So this would work.
Isn't that right?
Okay. Now, what about quadrant 1? Tangent is positive, right? Because the xy values are positive. What about here? My y value and my x values are negative. Could I have a negative tangent here? No. What about here?
Yeah. You could, but it doesn't fit sine's requirement.
That's right. It doesn't fit this criteria. So we have to live in what quadrant?
4.
Quadrant 2.
Isn't that 4?
Yeah, this is 4, but sine isn't positive in 4.
No, but isn't it?
It goes quadrant 1,
Oh.
quadrant 2, quadrant 3, and quadrant
Oh, whoops. I thought it was
4.
the opposite.
1, 2, 3, 4. So that means there is a triangle that exists here. And then my y and my x, which one is negative, the y or the x value? X. So this has got to be -1, comma 1, or something like that, right? -1, comma 1. Would that fulfill this requirement here?
Yes.
Okay. What angle is this?
45.
45, right? 45-degree angle. Now, what's cosine of this? Oh, so if I have a triangle, And my reference angle is 45 degrees, and this is, well, it's -1 because of the direction, but the length is 1. Off the top of your head, who knows what this is?
Square root 2.
Square root 2, very good, ma'am. So then this is going to be my adjacent, this is going to be my opposite, this is my hypotenuse. So we wanted cosine. Well, cosine of theta is equal to the adjacent over the hypotenuse, which is equal to -1 over the square root of 2. We don't like square roots in the bottom of a denominator, so we rationalize. And so we get -√2 over 2. Let's see if that's one of our options.
That's a G.
-2. Hey, that's the right.
Negative square root of 2 over 2. Snap, snap, snap.
Golf
Wait, what's
clap.
that from? Should we do